Start recording. Also, let me share my screen. Okay, I hope you guys are able to see my screen now. All right, this is the Forge online bootcamp for April 2022. My name is João Martins. I'm a Forge developer advocate, and I'm going to cover this session with you. All right. Actually, I'm doing today and tomorrow sessions on .NET. This bootcamp is focused in going through our basic tutorial with the first steps on using Autodesk Forge platform. Right. About the event. This is how this bootcamp is gonna work. We'll have 4 days, and each of them covering one specific tutorial with parallel tracks for Node.js and .NET. This one is the track for .NET. If you want to learn about Node.js, we have a parallel track going on right now with my colleague Jaime Rosales. He is close to me. And each day will be divided into 4 sessions, separated by short breaks, all right? And during a session, we'll go through the steps to build our samples, and you can follow along. Between the sessions, we'll have short breaks for you to post your questions. For that, you can use the Q&A. I'll ask you to please use the Q&A, so it's easy for everyone to share ideas and to see the answered questions in a good way. And also, in the breaks, we'll have time to grab your snacks and drink some water, in my case. We'll be recording this whole training, as you can see, as of now. I'm already recording it, and it will later be published, I guess, probably on YouTube, or maybe we do a blog post. We'll decide it. But the important thing is that we have access to the recorded content. All right, this is the schedule for the week. These are the trainings for each day. So today, Monday, we'll do a simple viewer covering the steps to upload a file to our servers, translating a file, and previewing the 2D and 3D designs. We'll go through each of these steps, and everything will be great. You will be in great shape for understanding how this works. All right. Tomorrow, we'll have the Hubs browser. It's basically the same app, with the difference that today is focused entirely on the Forge application, and tomorrow it will connect to a hub, being an ACC hub, being 360 Docs, and others such as Fusion Teams, for instance. On Wednesday, we'll have the dashboard tutorial. We'll take one of the apps may build either today or tomorrow and add dashboard to customize the viewer, querying design data and adding more information in a graphic way. On the last day of our tutorial, which is Thursday, April 28th, we will build a configurator using Design Automation API, modifying your designs with the Design Automation services. All right. This is the day one, simple viewer with .NET. This is the link for the tutorial. And this is our goal for today. This is the application we are going to build. It's a basic application to help you understand the basics of our platform. It takes advantage of our APIs to manage your data. You're going to upload, store, take advantage of the permissions, and render the result in a browser, render your designs in a browser, as you can see on this GIF. We are going to use OAuth for permission control, data management for storage, and model derivative for translations, and viewer for rendering on the browser. It all makes sense in the next sessions. Now let's talk about the agenda for today. On the session 1, this one that we are going through right now, we'll have an introduction and setup. I will tell what you need to download and what is the preparation so you can build this application. We'll have a break of 30 minutes where you can post your question. I'll be answering on Q&A. And after that, we'll have session 2. On the session 2, we'll cover the basic server and authentication. Again, once more, we have another break. Then session 3, taking advantage of the model derivative API, for instance, and data management to upload and to handle the upload and the translation of our designs. On session 4, we'll build the client side, the front end of our application, including the viewer setup. All right. Let's go with the session 1. Session 1, first of all, we have prerequisites. First of all, we need a Forge account and a Forge application. You must have an Autodesk account to get a Forge account. And as soon as a Forge account is created, you get full access to all Forge services for a limited time period. As of now, you have 90 days with enough credits to test all of our services. With a Forge account granted, it's time to create a Forge application. Registering a Forge application grants you permission to use the Forge services. At registration, you have access to unique credentials regarding your Forge application. Those are the client ID and the client secret, and they are used to identify your application. This means that the client ID secret will enable your application to access the Forge services across all platforms. And the Forge services utilized by your application will be charged for your Autodesk account, your Forge account, all right? So you have a Forge account, and you can have many applications, all of those using the credits on your main account. We also need an IDE. The other prerequisite that we have is an IDE used for development of our sample. As we are doing .NET development, I'm gonna use the Visual Studio Community, the version 2022, but you are also free to go with the Visual Studio Code later. But if you want to follow along, please download the Visual Studio Community. I'll show you in a few seconds how you can get it. Actually, through this link right here, I'll show you how it looks when you have the Visual Studio Community installed. Also, we use the long-term support versions for all of our tutorials. Long-term support version has a support in a long period. So in this case, as of now, the regular version for LTS in .NET is the version 6. So we are going to build our application with .NET 6. And this is a requirement for our environment. All right, enough talking. Let's go demonstrate. Let me demonstrate to you what we need right now. This is my Windows. Hope you can see it. First of all, let me go to Chrome. And we need our Forge application, our Forge account. So you can go to our platform, and then if you are a first-time developer, you don't have a Forge account, you can go through here to the Getting Started. And this will help you to go through the creation of your account. We have our start here, and then we have the sign up option. Once more, you must have an Autodesk account to get a Forge account. If you don't have it, we need to create first your Autodesk account, and then you click on sign in to enable your Forge account. Your Forge account comes with credits for 90 days, with enough credits for you to test all of our services. As I already have one, I can just click on sign in right here. And in here, we need to type our email. In this case, this is my Gmail account and the password. And okay, I logged in. Now we need to create our Forge application. Is the second step for our tutorial. So we can go under our user and click on My Apps. In this case, I have a few applications as I did a few tutorials. But if you are doing this for the first time, you'll have an empty page here. So you click on Create an Application, and you'll be prompted to a page to add information about your application. Let me type Bootcamp, simple viewer. You can choose your name one of your preference. We also need to specify an app description. App for Bootcamp tutorial, for instance. Callback URL. We are not going to be using the callback URL today. We are going to use it on the session tomorrow, but as of now, if you'd like, we need to provide this field. So as of now, if you want to do it consistently, please type the value that I'm going to post you on the chat window. I just sent to you all, and it'll be good to go. This session here controls which APIs our Forge application will have access to use. Today, we'll be focusing on data management to handle our designs, also on model derivative to translate our designs, and that's it for today. But for tomorrow, for instance, we might take advantage of B360 or ACC and so on. Just for simplicity, I'll leave all of them available here and just create the app. But keep in mind that this will control which APIs your Forge application will have access to, all right? So we click on create our application. All right, and we have our application. And the most important thing that we are going to use are the credentials of our application. This will grant us access, grant us permission to use Forge services. The credentials are the Forge Client ID and the Forge Client Secret. All right, now the second prerequisite that we have is the Visual Studio community. Let me paste it right here. This is the address for you to grab the Visual Studio community. So you click on download Visual Studio, and you need to ensure that you have the proper workloads. In this case, we are going to need the desktop, the ASP.NET and web development workload, this one right here, and also the desktop is good to have, even if you it's mostly important for the last day of our session, where we're going to build a design automation sample. All right. When you're ready with the Visual Studio community, you're gonna have something like this: Visual Studio 2022. And if we go under continue without code, for instance, we can check under tools. And let's go to options. Oh, sorry, not options. It is tools, get tools and features. You can check the content installed with this instance. In this case, we need both of these right here. Let's just wait for it to show up. ASP.NET development and desktop development and individual components. We need the .NET runtime of .NET 6. This is what we are going to use today. All right. Now let me go back to my slides. And this is your third. You need to create a Forge account and then create a Forge application to grab the credentials and also install the Visual Studio Community 2022 with the proper workloads for ASP.NET development, web development. All right, is everything clear? On the next session, we will cover the creation of the basic server and authentication. All right, I think we have a question here. Let me check. Yes, .NET 6 runtime. Yes, Moses, you're right. So we have a lot of time to the session 2. now is the time that I have to ask you a question. What do you think? You need 30 minutes break to install everything, check that you have everything, or do you want to go through the session 2 right as of now? I'll ask you to raise your hand if you want to continue right now without a break time. Because I know that if you already have your Forge application and your Forge credential and Visual Studio Community properly installed, you can go right now to session 2. So if you want to move to session 2 without a break, please raise your hand. Thank you, Liz, Moses. 10 minutes to catch up. Well, I have to give you 30 minutes because more than half of the participants wants the 30 minutes. So as we are all in an agreement, you'll have 30 minutes of break. So you can take advantage of, please ensure that you have your Forge application, your Forge account properly defined, and the Visual Studio Community 2022. All right. See you back in 30 minutes for now, 30 minutes from now, and that's it. If you have any questions, please use the Q&A. Start the recording, and it is recording. Now let me share my screen. And now 2 our slides again. Okay, now we take care of the session 2 for the building the server and also taking care of the authentication. All right, this is the architecture of our application that we are going to build today. And we can separate our application into 3 layers, actually, as you can see in this diagram right here. We have the Forge servers, where our data is stored, and you can access our platform services, such as data management to store your designs, or model derivatives to translate your designs. We have the Forge, we have to access these services and data, we have the OAuth 2.0. We have authentication based in token acquired with your Forge application credentials. And this is what we are going to cover in this session also. We are going to build the client side or the front end and the server side using Visual Studio Code, your Forge app, and all of the setup that I'll show you right now. All right. The server side will provide our static files, such as the HTML, JS, and CSS, to the client side in a way that the end user has direct access. Those files are responsible for building the user interface, the buttons required to build the whole structure of our page to show the models and so on. All right. Using the UI of our application, the user will connect to Forge APIs through the server side, always through the server side. For instance, let's say we want to retrieve all of the designs available for this account. So we'll have a controller, a method on the server side. Client side will reach this method, and this method is going to retrieve the available models from the Forge services, and then it's going to show it back to the client side through a list or through a combo button, and each way you decide. In this case, we'll have a combo button, a drop-down menu with all of our designs available. Except for rendering the translated model with viewers, except for the acquiring the models to show on the browser, all of these tasks are doing through the controllers, through the server side. This is the only case where you're going to call our Forge services directly from the client side, which is for retrieving the translated model. All right, now let's talk about the application setup. The first step is create our app setup. We're going to initialize a new project and install the dependencies. In this case, we only have one dependency on server side, which is the Forge SDK. And also we need to prepare the app configuration through the startup.cs class and launch our configuration through appsettings.development.json. Here we are going to store our environment variables. In this case, we need to provide the Forge client ID for our Forge application, the Forge client secret also from our Forge application, and a bucket name, for instance. We are not going to provide it, but during the next session, I'll go in more details on why we need to provide a bucket name, what's a bucket, and how it's used on our platform. Also, we need to create our basic server, in this case through program.cs. Program.cs is the entry point of our application, and it will be responsible to register the startup.cs and create a host using the iHostBuilding instance in the main method. The startup.cs will handle the configuration of our application, including the environment variables, the static files, routing, and controllers, so on. We have a configure method that's used to specify how the application will respond to each HTTP request. You'll see more details in this session. We also are going to create our authentication methods. We have authentication is a base for accessing the data and services through a token-based authorization. And for every request, a valid token is needed. Let's say we need to create a bucket to store our files. We need a token for that. Upload a design, we need a token for that. Trigger a translation, we need a token for that. In this sample, we'll have a class called forgeservices.cs. In this class, we'll handle our calls to Forge services, and the controllers, in this case, we'll have a auth controller here. This controller will handle the calls from the client side. So the path is just like the diagram that I showed earlier. The client side will reach a controller, an endpoint on our controller, and this controller will use a method from the Forge service class to reach the Forge APIs, the Forge services. All right. Controllers handle the interaction with end user, and the models will handle the logic in our application. Enough talking, let's go build it. Oh, we have a question. We have a question here. Let me check it. Okay. We'll have access to the recording. Yes, João Pedro, you have access to the recording. I'm not sure if through YouTube or a blog, but the answer is yes. So first of all, this is the tutorial we are going to build. This is the simple viewer that we build today. We have two more tutorials. This one will be covered tomorrow, and this one on Wednesday. So let's go to the application setup. I'll send you the link of the step that we are right now. Sending through the chat window. Supposed to have it. So first of all, we need to create a new project in Visual Studio Community through this option, create a new project. And then we need to choose the proper template. We are going to start with the ASP.NET Core Empty template. Then we need to select a name for our application. That's on you. Choose the one that best suits you. I'll place the solution and project in the same directory just for simplicity. And this is required. We are going to use the long-term support version, as I said on session 1. And in this case, is the .NET 6. Liz is raised at hand. Liz, do you want to ask something? No? Alright, so let's move on. After that, we need to create 3 more folders on our project. The controllers folder that will handle our controllers, the models will handle one specific class, the Forge Services class, and the wroot folder. Wroot folder will contain all of our static files, such as HTML, CSS, JS, JavaScript, and image, and so on. Next, we'll need to install the dependencies. In this case, only the Forge SDK. So we'll go to the manage NuGet packages and install the Autodesk Forge with the latest version, latest stable version. In this case, it's 1.9.0. Let's do this first, and then we go back to application config. So let me close this one right here. We have one new message. Moses, I don't have .NET 6 runtime. You need to download the .NET 6 runtime to follow along, Moses. That was in the first step. Okay. Oh, you have it? Okay. So let's go. First we create a new project. And now we choose the estimate core empty. It's right here. If you filter by C#, Windows and Cloud, and we click on next. Now we select a name. Let me call it Simple Viewer. Simple Viewer dot no. Let me call it day 1. I'll place the solution and project in the same directory, but feel free to choose your own. Click on next. And also we need to select the .NET 6, which the LTS, and also unselect this configure for HTTPS. We are not going to use it for these simple purposes. Next, we click on create to create our sample. Take a few seconds. Okay, now it's time for our dependency. Just a few more seconds. And it should be good right now. This is what comes with our project. If you have more than this, probably you selected the wrong template. It should be empty, and this is the minimal requirement. So to add our dependency, we can right-click on the name of our project and select this option right here, Manage NuGet Packages. So from there, we can go to Browse panel and type Autodesk Forge. As soon as we press enter, we should be able to find, and we are going to use this one right here, only Autodesk Forge, and the latest stable version, 1.9.0. So we click on install, accepting its dependencies, in this case NewtonSoft.json and REST sharp. It is installing, and if you go now on the dependencies and packages, we can see our brand new SDK Autodesk Forge version 1.9.0. Alright, so this step is clear. Let's go to the next one, which is application config. For the .NET 6 and Visual Studio 2022, we need to create the startup class. Oh, sorry, missed one step. We also need to create 3 more folders: the controllers folders, models, and wroot. They don't come by default as we have chosen the empty template. So first, let's create the controllers folder. Let's copy this name. And under the name of the project, we right-click and select Add, New Folder, and we paste the name that we just got. Next step is the Models folder. Once more, right-click on the name of the project, select Add, New Folder, and we paste it here. And then we have our wroot folder. This folder is a default folder for storing our static files on the .NET projects. So as soon as you create it, it will change the icon, showing that this is a default folder right here. It changed the specific icon, right? So as of now, we have the required to go to the application config. So our application, as I say here, our application with a couple of configuration inputs should run properly. For example, the credentials of our Forge app. This is what we are going to handle right now. So we need to create this class right here, startup.cs. So for that, we go to our project, right click, select add new item. We are going to build to add a controller. Let us do it here. Let me check it here. API controller empty. Now paste the name. Oh no, sorry. This is just a class. This is not a controller. It's just a class. Alright. Our startup class comes with this content by default. We can get rid of that. And we are going to paste our content from our tutorial. Let's copy this. We can copy with a single click on this button. And now we can paste it here and press save it. Alright. And here, as you can see, we are adding the controllers and handling the Forge client ID, Forge client secret that we get from our configuration JSON. Alright. We also handle the Forge bucket, and in here we have a check to see if at runtime this application is provided with the Forge client ID and secret. If not, and for any of those, we are going to raise an exception saying that we are missing the environment variables. Without the environment variables, we don't have a way to make it work. And this is the default configuration for using static files under wroot, for instance, use default files, developer exception page, and the mapping the endpoints and routing. All right, this step is covered. Now we need to pass our development for our application. All right, so this is done through this appsettings.development.json. We need to paste this content on our .settings.development.json, so we can go there. We don't have appsettings.development.json right here, but if we expand this option, we can see this JSON file. So we can get rid of the default content once more and paste the one from our tutorial. And in here, we need to select our specific client ID, our specific client secret, and the name for our bucket. The name for our bucket must be globally unique. So I'll say I'll leave an empty option here, so we can see how it works in the third session. This application handles it in a different way to specify that our bucket name of our bucket is globally unique. We'll see that in the next session. Now let's focus on our Forge client ID and Forge client secret. Let's go back to our Forge application, and then we can copy our client ID. Let's replace this one right here, and also the Forge client secret. Please be aware that this is confidential information. This is secret information. So with this information, anyone can access the Forge services under your account, consuming your credits and having access to your data. So this needs to be really well maintained. You can't expose this secret as I'm doing right now, for instance. So if you expose it, you can simply click here on regenerate, and it will generate a new client secret for us just in time. And the previous one will not be able to access our data, right? We also need to ensure, another thing is, if you're using GitHub, for instance, you need to add an exception to not add these appsettings.json to your repo. So otherwise, you're going to expose again your client secret and client ID. I think this is mentioned in this this tutorial. Yes, it's mentioned right here. Since the app settings.development.json file contains sensitive information, let's make sure it's not included in Git, all right? This ensured by adding the app settings.development.json line to the Git ignore file. All right, now we just need to take care of the program.cs class. Let's go. This comes by default from our application. This is a new thing. It is a new tool from a new configuration for .NET 6 projects. It has implicit usings, so it's already using system, for instance, in a way that's easier for you to build a sample, to build a first run application. It's really cool for testing, but for this purpose of this tutorial, let's keep with the structure from our sample, our tutorial. All right. We're just creating a host, a web host, and also adding the startup class to handle the configuration. All right. Now we need to configure the specific port that our application will be using. And for that, we need to change the application URL under the launch settings.json file. In this case, we are going to use the port 8080. Let's copy this content right here and go to our properties, launch settings. Under application URL, it comes with a random port. And let me paste this content. Okay, which might be good now. Everything is the same. And now we can try it out. And as of now, we don't have a client side. We don't have any page, any controller, any method at all. So we are going to see an error in 404, meaning that we don't have content to show. But we can check already if our application is retrieving the client ID and client secret. Let's go do it. As you can see, at runtime, it's going to call the setup.cs class. So we got to the breakpoint. Now we are trying to retrieve the forged client ID and forged client secret. Let's check it. And here we have our forged client ID and also the forged client secret. Okay. The forged bucket is an empty string. And now we are verifying if we have the forged client ID and secret. If you don't have either of them, we are going to raise an error. And that is not the case because we have both. So we click on continue. And then we can see a page with a 404 message because we don't have any content to show. And this is good. This is by design because we have nothing to show really. So we can click and paste our application. And then we can go to our next step, which is the authentication. All right. And first, as I said before, as I mentioned before, the forged services uses a token-based authentication to handle your requests. And this is the class. These are the methods used to retrieve this token. We are always going to provide the forged client ID, forged client secret, and also the specific scopes to retrieve a token. And through the scopes, we can control which services and which tasks, which actions our token is allowed to do. In this case, as a good practice, as it says here, we have two tokens. If you remember from the diagram that I showed before, we have the server side doing all the requests for servers, and also there's one specific request that is made from client side. So for this request, we'll have a public token, which is only have the scopes to view your designs. And for the other requests that we call on server side, we have a token with more scopes, with all of the scopes required to create a bucket, to upload a file, to list the files inside the bucket, and so on. This is what we are doing in this case, all right? For that, first of all, we need to create a class called ForgeService.cs under the models subfolder. Let's go there, model subfolder. Right here, we can right click on it and add a new item. And now we can add a simple class with this name. We paste it and we add this class. We can get rid of the default content, and we can copy this content from our tutorial. Alright, and in this class we have defined the client ID, client secret, and bucket name, and we also have a verification, have a step to verify. That's why I left on empty our bucket name. So this sample, if we don't specify a blank string, empty string as a bucket name, it's going to use our client ID with the suffix of basic app to create a unique bucket, because all of the buckets must have unique names globally. This for the entire service. That's why if you try to choose a bucket with the name, let's say my test bucket, it won't pass probably because someone might already have it. Let's get back. Now that for service is declared as, alright, that's one more thing. We are declaring this class as partial because for each of our models, we have a models for authentication, we have methods for authentication, we have methods for managing the data and the derivatives, and those are separated into different files. But all of these files are partial classes from the same class, which is the Forge Service class. This is a way to handle it in a better way. This is a way to make it easier to debug and have a large class with lots of logics for our services. All right. So now we need to create also this class right here, which is a forgeservice.auth.cs. We need to create this file under the same folder. And as soon as you create it, you'll see that Visual Studio will show in a way that is under our main class, Forge Service. So if we go right here, we can get rid of the default content, and we can copy and paste the content from our tutorial. Let's paste it in here. And in this case, in this file, we'll handle the methods to get the token, and from the token we get the public token and the internal one. All right. As I said before, the public token that is shared with the client side only have the scopes to view our designs, and the internal token has more scopes to create a bucket, to create and read buckets, and create, read, and write data on our buckets. All right, let's see what else is missing from this step. We also need to add a line on startup.cs. This line right here, to add a singleton to services. This line is responsible. Let me copy it and paste it under startup.cs. Let's go back, startup.cs. In here, we can add a new line and paste it. And paste it. Okay. This is a dependency injection that we are doing for the Forge service class under our services. And this is responsible to make sure, the singleton right here is responsible to make sure that we have only one instance of this class. We don't have, so this is good because in this class, we are defining the client ID and client secret and so on, the token, for instance. So we make sure, through this, we make sure that we are dealing only with the same environments and the same tokens through the whole application, all right? So we are not grabbing new tokens randomly, for instance. So I think that with that, we have the controller is missing, the off controller, and then we might be good to test our application. We go under our controllers folder and add a new controller. We can choose the empty one and paste the proper name from our tutorial. Now we paste the content from our tutorial also. Paste it here, save it, let me save it all. And in here, this is the endpoint that our client side is going to reach. So our client side is going to reach this endpoint, and through that, it's going to define the public token internally, externally, and also at the same time it will grant the internal token. We have the public token shared with client side and internal only on the server side. All right. This is what it does through this endpoint right here. Now we are good to test it. We can go on and test our application. Let me add a few breakpoints here. Not only this one. This one is good. And as of now, we have also again the 404. And this is the right way. This is not wrong at all because we don't have UI. But we already have our controller. We can use this controller. We can reach this controller through the endpoint provided. In this case, is this one right here. We can copy this value and paste it right here. As you can see, we reached our breakpoint, and this controller is going to take us to the for service class to get the public token. Let me go back to the controller. Let me edit one more here. Continue. This is grabbing the token, and as you can see here, we have a new valid token. A token comes with the time of expiration, and this is good. I didn't mention a token is valid for 1 hour after we get one. So we get the token, we can use it for 1 hour, and after that we need to refresh it. We need to grab a new token. This application is handling it for each request that we made. And as we reach this endpoint through our browser, we are going to be able to see the return in the browser itself. In here, we can see our access token and also the expires in seconds. All right. Good, cool, isn't it? Okay, so let me go back to slides. Now is your turn. Application setup with the startup, application development.json, and program.cs, and also our main class, use it for the whole application, the for service.cs, with the partials for authentication, and also the off controller. Build those and make sure you test it through just the way I did. The steps are in the tutorial. I think I posted it. Yes, I posted the tutorial. And I see you in 30 minutes for session 3 with the upload and the controllers to upload and translate our models. All right. Any questions? Have any question? If you have any question, please use the Q&A. Feel free to drop it there, and I will answer as soon as I get back. Let me record again. Okay. I think you can hear me now. I can see the levels raising. Sharing the screen. And now the presentation. All right, now let's talk about session 3. On this session, we'll handle our methods to upload and translate our designs. Okay, we'll be adding the logic to upload our designs and trigger the translations. This logic is handled using the same class. In this case, with the file called forgeservice.oss.cs, and also for the translation with the forgeservice.derive.cs. It's called this way because OSS is the service responsible for handling our data, and model derivative is the API to translate our models. We are going to add also the server endpoints through the controller models controller.cs. After we upload a file to a bucket, we have actually, first of all, we need to talk about OSS. Under OSS, which is the storage service for the Forge platform, we have two entities. We have the buckets and the objects. Our file will be stored inside a bucket as an object. You can think of a bucket just like a folder, with the difference that in our specific bucket, we can contain only objects. We can store a bucket inside a bucket, just like we do for folders, for instance. And also, when we create a bucket, we need to specify the region it's stored, and also the specific policy. We can create a bucket with 3 types of policy: the transient, temporary, and persistent. If we go with transient policy, the bucket will restore our files for 24 hours. The temporary will store our file for 30 days. And if we go with persistence, the bucket will store our files forever until we delete the file or the bucket. All right? And after that, we need to trigger a translation to be able to render our model in the browser. And this translation is done through Model Derivative API. This translation can take one of our inputs files with more than 60 formats supported and translate it to SVF or SVF2. Those formats are available to be seen through Viewer with the browser. Right? Let's go demonstrate it. And for that, we can go to our documentation. First of all, let's see the overview of the model derivative. It's better if we go through our data management API first. We have here the overview of our API, the schema, everything. The API basics is recommended. Tomorrow we'll cover all of these steps here, of all of these layers, but today we'll be sticking to this OSS service, which contains the 2 entities that I just mentioned, the objects and buckets. So let's say in this sample on the session 4, I'll grab a Revit file, and then the first step is to upload this Revit file to one of our buckets. From there, we are going to trigger a translation. As I said before, when we are creating a bucket, we have 3 types of retention policies: to store our files 24 hours, for 30 days, and persistently. So this last way, the file is not deleted until you delete the file or delete the specific bucket. Also, it's valid to mention that our response is paginated. What we mean by that is that, let's say we have a bucket with 1,000 objects. We can't retrieve all of the 1,000 buckets in one request. So we need to keep calling the request with the paginated results. We have one question right here. Are the hub folders a type of buckets? No, Moses. We are going to get there tomorrow, but in advance, I can say that as your question, a bucket for the user-specific storage type, such as Bin360, ACC, for instance. We have buckets underneath, not controlled by the Forge application, but in each bucket, we'll have all of the available versions for your project. So inside your project, you have hubs, projects. Inside your hubs, you have projects, folders, and items. And inside each item, you have all of its versions. At the end, each version will be an object inside a bucket managed by the product itself. So this is an information for the session of tomorrow. Please, I hope I see you there, Moses. We can discuss in more details, but let's stick with OSS, the service that's used for all of the types. Thanks, Moses. So as of now, we are going to use OSS with our Forge application independently of our products. So our Forge application will have access to all of its buckets, and that's it. The only through this application that create the bucket, you have access to manage this data. Only through this client ID and secret, I'll be able to manage my buckets created through this application. That's why the client ID secrets are so important to keep secret. So you have your designs, you have your data, and this is what grants access to this data. Okay? So, okay, it covers model derivative. This is the object storage services. And also, apart from there, once we upload the bucket, we need to trigger a translation. Viewer renders the models, the designs on the browser based on a specific format. And this format is called SVF, Streaming Viewing Format. And we have also the SVF2, which is a improvement of the SVF format that's brand new. You can choose between either of both to render on viewer based on the input format. And what does this conversion? In my case that I'll be doing here is from Revit to RVT to SVF is the model derivative API. Model derivative API can be used to do file translation, and we don't have only this, we have more translations available. It can be used to generate the thumbnails for your drawings. It can extract the geometry, specific geometries, and the data. When we translate a model, we translate the geometric information, the textures, and also the metadata. Let's say we have a wall. A wall don't have only the geometry and texture. A wall can have a thickness, can have a length. So all of this is extracted through model derivative API. This is our documentation for model derivative. And also what's really important is here. If you go under supported translation, we have all of the available translations, all of the supported formats. What I'll be doing is this one right here, RVT, right here. This is what I'm gonna be doing from RVT to SVF. It also generates the thumbnail, and as we are doing the translation to SVF to render using viewer, I could also use the model derivative API to generate DWGs for specific views of my Revit files, or also convert it to IFC, which is a common standard, all right, across products. So feel free to go to our documentation. It's strongly recommended. We also have step-by-step if you want to do other tasks not covered in this tutorial. Now let's focus on our tutorial. Next step is data and derivatives. All right, now we need to add one more file under our models folder, which is this one right here. It will extend our class, and this time to handle the data management API. We are going to list the objects that we have on our bucket and ensure the bucket exists. In this case, I entered an empty string, so it's going to do something. And also we are going to upload a model to a bucket. This is to ensure the bucket exists, and this is to upload the model. So let's create the Forge OSS.cs class, copy the value. Now we go to models folder, right click on models folder, add new item. I need to add a class, paste it. As soon as I add it, it will also be under the Forge Service main class. And this is a partial, right? Please note that we are always using the same class for service, it only through separated files. Now we paste it and save it. All right. It's also handling the pagination, I guess. Yes. While we don't have, as I said before, the response is paginated. So if we have more, let's say 1,000 objects inside a bucket, 1,000 files, you need to keep calling the request for the first 200 and the next 200 and so on. This is handled through these lines right here. All right. Okay, so let's go back. Now we talk about the globally unique name. In this case, the samples is going to use only one bucket, the bucket that we specify on our app settings.development.json. In this case, I didn't specify any name, so under the ensure bucket exists, it will retrieve an exception when it tries to get the bucket details, because we don't have a name for the bucket. So it's going to create a bucket with the bucket key. And in this case, the bucket key, I guess it's from startup.cs, if I'm not mistaken. No, for service. Yes, and the bucket key, in this case, there is a check here. If the string is null or empty, we are going to use your client ID. The client ID is a unique client ID with the prefix of basic app. So this name is globally unique. We'll grab this name and create a bucket, right? So through this line here, we are going to create this bucket, and then it's going to be used to upload our models. Cool, isn't it? Also, I spoke about the authentication. This is where we retrieve our token. And as you can see, for every test that we are doing to connect to Forge services from the server side, we are always using the internal token. The internal token, once more, is the one that we have the scopes required. Here, I'm ensuring the bucket exists. So in this line here, for instance, I'm going to read the details of a bucket. I'm going to read bucket. In this line right here, I'm going to create a bucket, always with the internal token. Let's go to definition. Internal token has the scopes to create a bucket, to read a bucket, to read data, to create data. All right. So that's why we are using the internal one. And this is not shared with the client side. This is really important also. When we upload a model, once more, here is the internal token. And we get the objects, once more, using the internal token. On the last session, we'll see how we are going to use the public one, the public token on client side. All right, we covered it. Now we need to translate our models. In this case, we will grab the uploaded file and pass it to an endpoint called postjob endpoint. And through this postjob, we are going to translate the specific model to SVF, as it's done right here. For this, we are going to create a new class, create a new file, the same class for each service. If you notice, it's always this class right here. So we right click the models folder, add new item, add a class, paste the content for service.edit.cs, and now we get rid of the default content. We copy the content from our tutorial. As you can see, always underneath, always below our Forge service class. And now we paste it. All right, here we have a function to encode our URL, our name, the name of the reference used for this API, because every time we use a reference to translate a model, it needs to be base64 encoded. So that's what this function right here is doing. And this is and we have two main functions, two main methods here. One to translate our model. Once more, we are using the internal token, and this is the way it is done through our SDK. We need to provide the output format that we want. This here we are specifying that we want the 2D view and the 3D view. Always, let me see it here. Let me add the 3D view here. Yes, we don't want the 2D twice. Okay. Now we are encoding the object ID. The object ID is a URL containing the name of the bucket and the name of your object inside the bucket. As the name of the object, the bucket is unique, we have a reference for a unique file inside the whole platform. We have one bucket that's your own. Only your bucket has your globally unique name. And also the object ID, the name of the object inside the bucket must be also unique. We can't store like the Revit file A, upload it to a bucket, and then upload again Revit file A. It should be Revit file A, Revit file B, Revit file C, for instance. A file can be only stored once with the same name inside a bucket. Okay, and also we have a function, a method to retrieve the status of our translation. So what it does, when you trigger a translation, it might take some time, and this time depends on the complexity of your model. Let's say upload a large Revit file with lots of objects and lots of textures and lots of information. So it might take some time, a few minutes maybe. So in order to check if the file is ready to be shown, we need to return the manifest. The manifest contains, among other information, the progress of our translation. So I trigger a translation and I retrieve the manifest. Once the file is ready to be used, to be rendered through viewer, we are going to receive the status with a success option. So the translation of the job, it has succeeded, is ready to be used. So only after that we can grab our derivative, our SVF, to show on the browser through the viewer API, right? Let's go back to our tutorial, and also we need to create a new controller. In this case, it will be the models controller. Let's go back to our controllers folder, add controller, MVC empty, and paste it. Models controller. Wait, once more, you are used to it, right? Get rid of the default content and copy and paste the content from our tutorial. It's always good to remember the controller grabs the request from the client side and uses the forest service class to handle the connection with the forest services. All right, we are going to, for instance, get the objects through this endpoint. Through this endpoint, you'll get the status of our models. We are going to upload our models, upload and translate our models. All right. This controller will handle 3 types of requests, as I just showed you before. And we are good to go through this session. And we can use, once more, we won't have any information to show to the client. The client side will be on the last session of our tutorial. But we can test our controller that we just added to our sample through this endpoint right here. That's what we are going to do right now. Let's push play. building. Let me use this time to drink a cup of coffee. Okay, it's good. Oh no, 404. It's good, no problem at all. We need to try with this endpoint right here. And this endpoint will retrieve our models available. It will be this one right here, get objects function. Let's go there and paste this, press enter. Okay, now let's go into our function, get objects. Let's go to it. And this is going to, first of all, ensure our bucket exists. Let's go see how it works. First of all, it's going to grab the internal token. Okay, we have the internal token. We are passing the internal token to the API object. And now we are going to get the bucket details. But remember, I created this application. Now you saw it, and it didn't create any bucket. So you will receive an error. All right? Because there's no bucket to get details from. So if the error code is 404, in this case, it means that we don't have a bucket to read details. So we need to create a bucket. Now we have our bucket. And we can get an internal token to retrieve the objects from the bucket that we now ensured that exists. All right. This part is just to make sure that the bucket exists. Now we'll have a list to retrieve the objects. And as we just created a bucket, it doesn't contain any object at all, right? We just created it. So it's an empty bucket. In the response, we should have an empty array. So we'll add it to result and we show it back to the user. I think it's from here. Let's add a breakpoint here. Objects is an empty array. We don't have any objects at all. This is what we are going to pass back to the client side. As you can see here, empty array. All right. But this is good. This is intended because we just created, but this bucket don't have any object at all. All right, and this is the goal for this session. We have one more. Let me share my slides again. Now is your turn. Logic for listing and uploading files, logic for translating designs using model derivative API, and adding the server endpoints through models controller. On the next session, next and last one, we'll cover the client side, the user interface, the buttons, and the lists of objects inside our bucket, so on. And we'll render our designs using the viewer. All good? Hope to see you in 30 minutes for the next one. 30 minutes is good for the next one. If not, please leave it on the chat window. Okay, so see you in a few minutes. Review how to create a bucket. All right, I'm going to review it. Let me why I stopped sharing my screen. All right, hope you can see my screen, Ronald. The bucket is created using the name that we define it. In this case, if we go to appsettings.development.json, I used an empty string. You can do the same if you don't mind the name of the bucket. But always remember, this name must be globally unique. So for this to work, your name of your bucket should be unique across the entire platform. Through this forge service that we just added right here, not this one, through the OSS object storage service, we are going to create a bucket. This line right here is the one that creates a bucket. It's passing the bucket key, which is the name, and the policy. In this case, we are using the temporary policy. So if I upload the file right now, after 24 hours, the file is going to be automatically deleted. I can delete it, for instance, right here, and add a persistent policy. So as of now, if I create this bucket, it will be created with a persistent policy, and the file will remain that forever until you delete the bucket or the file. So feel free to add the one that you prefer. And this line is the one that creates the bucket. All right, based on the name, and the token is defined here through the API object. All right, API new buckets API, and we are using the internal token. Once more, the internal token is the one that contains the scope to create a bucket. If you go to the definition, here we have the specific scope used to create the buckets. Buckets create scope. Is good, Ronald? Ronald? All good? Oh, awesome. So let me interrupt my sharing and see you in 30 minutes. We are recording. Let me share the screen right now. Sharing my screen. And okay, now we'll talk about session 4, last session, using adding the user interface and handling the loading of the model through viewer. All right. I see that we have 2 questions here. Let's go through it before we continue. First question is, I found a tool from Ronald. I found a tool that allowed me to create a bucket. Do I put the global unique name, bucket name in my code? How do I identify the unique name of the bucket? The options were US or EMEA. Choose US. These options that you are mentioning are the regions that we have when we create a bucket. Let's take a look at the endpoint that we are using from our documentation. If you go under our documentation for the bucket, to manage, once more, to manage our storage, we have the data management API. And under that, to create a bucket, we can go to the API reference, OSS, which is the service used, buckets, and post bucket. This is the endpoint used to create a bucket. You need to specify the content type, which is application JSON, the authorization with the token, the scopes the token needs to create a bucket is bucket create, and you also need to specify the region. We have 2 available options, US or EMEA, depending on where you are staying and the regulations required. And you also have the body structure. With the policy key, for instance, we need to provide the bucket key in the payload, and most important, also the policy key with the data retention policy. As I said before, we have transient, temporary, and persistent. Here, at the bucket key, which is a required value, just like the policy key, we need to provide a unique name for the whole platform that you assign to a bucket. It must be globally unique across all applications and all regions. Otherwise, the call will fail. Here are the possible values from A to Z, including numbers, and with the minimum of 3 characters and the maximum of 128 characters. And also, you cannot change a bucket key once it is created. You need to delete it and create another one. As you say, Ronald, you said you found a tool that allowed you to create a bucket. You can do it through a few tools. You can do it through Postman. You can also do it through Insomnia. I think that in our tutorials, we talk about Postman. Let's see, create an app managed bucket. Not sure if it's made using Insomnia, using the Postman. No, but let's go to our blog. If we go here to our community blog, we have a few available options. If you type Postman, we have all of these blogs that has Postman collections. Postman is a tool for testing and improving testing and creating your APIs. In this case, you can use Postman to do a quick search, to do a quick analysis on our available APIs, and we have collections for that. We have one here, for instance, talking about pagination with Postman. Probably this one here handles the refresh token with Postman, and so on. Let's talk about pagination with Postman, for instance. This is talking about our responses. As I said before, let's say we want to list all of the contents inside a specific bucket, but our API only provides 200 objects in a call, so we need to keep calling it like that. So we have plenty of content. Feel free to do a deep dive. I don't know. Okay, how could you do the semi Postman? Here is the link to download it if you want. It's a good way for testing. And we also have, I personally prefer, we have the Insomnia REST, which is the same thing, but with a different application. I find it easier to understand. And I started using Postman. Nowadays, I only use Insomnia. Feel free to grab one of these. We have collections for both. And I'm not sure if this is the one you're referring, Ronald, but we have a third one without the need of installing another application that you can see through the Forge showroom. This is also a great tool from our platform. Through this web page here, through this site here, you have access to all of the samples. Not all, maybe, but most of the samples that we built using the Forge platform. All right, we have samples for digital twins, plant operations, configurators, and so on. So most of our services are covered here. And we have one specifically to manage our buckets. Let me see if I can find it here. GitHub. This one is for app-specific storage, user-specific storage, and this one right here, buckets tool. If we go under the demonstration of it, it is a simple application where we enter our client ID and client secret. Let me go back right here. So we can enter our client ID, paste it here. Also our client secret, paste it here, and we can log in. Now we can see all of our available buckets for each of our two possible regions. For EMEA, I didn't create any, and for US, I created one bucket. And the name of the bucket, as you can see, is prefixed with our client ID, the same value, you see? RR, same value, finishing with CUI, and at the end we have basic app. And here we have our temporary persistent, our retention policy, sorry, which is temporary. In other words, the files that I upload here will remain here for 1 day. After that, 24 hours. After that, they are automatically deleted. If I expand this option, I'll be able to see all of the objects inside this bucket. As I didn't upload any object, we have nothing. But if I right click from this button, from this tool, I can upload a file to this bucket, or I can delete a file to this, or I can delete this bucket, sorry. But let's not upload through here. Let's do it from our sample. Would be better to understand how that works. That's the one I use it, buckets too. Alright, amazing, Ronald. You can also do that through Visual Studio Code sample, but as we are using Visual Studio, let's not focus on that. But if you go with Visual VS Code, feel free to check that. We have one more, is the instruction to change the bucket name. Also in the tutorial, we can change the bucket name, Moses, as I said as I went through the documentation. I think I closed it. Data management, post bucket. We have it here. Note that you cannot change a bucket key. Alright, Moses. Oh, but I think that you meant on the source code, right? If you create a bucket, let me put it this way. If you create a bucket, we can change the name. But from our source code, we can change the name that we are going to use it through the appsettings.development.json. So if we use another name right here, this is the environment variable that the sample is going to grab, and this is the environment variable this is the bucket that we are going to see through the user interface. All right. So that's covered. Post bucket. Okay. Now let's go back to our presentation. All right, now let's cover the session 4, viewer and UI. We have one more question. If you delete a bucket, can you reuse the name? Yes, if you delete a bucket and nobody is using the name anymore, you can reuse the name, yes. Every time you create a bucket, it must the bucket key must be globally unique. So I use let's say the bucket A, nobody got bucket A. I created, okay, it's there, it's mine. If I delete it, it will be available. So if anyone uses the name, it's not available anymore, all right? That's how it works. All right, on the last step, we are going to add the viewer logic under the wroot folder. We are going to create a JS file called viewer.js. We also are going to add a logic, the application for logic, the logic for our application. And by that, I mean the logic to our buttons, how they work, to the drop-down menu, how it works, what it triggers, and so on, what we have on our layout, and also the HTML page. Under wroot, once more, styles using under the wroot folder with the name of main.css, and we can test it out. We can use a Revit file, for instance. Now let's go, enough talking, let's go to the demonstration part. This was the last thing that we did before our break. Next, we have viewer and UI. So first of all, we start the viewer logic through this file right here, viewer.js, that we are going to create inside our wroot folder. So we go to our wroot folder. As of now, it is empty. We can right click on that, select add new item, and we are going to add a JavaScript file, and the name is the one that we got from the tutorial, viewer.js. Okay, it got created. We can copy the content from our tutorial and paste it right here. So we have 3 main functions that are being exported to our main application, to our main JS file. And these functions are are the steps to initialize the viewer on the browser. Here we are defining an extension. I'll be talking about an extension when we have the user interface, and I'll show you how you can get all of the extensions available, how you can take advantage of those. And when we are initializing the viewer, we also need to grab the token. So we have this function to use the token, to pass the token to viewer. And in this case, this function is retrieving the public token. Remember when I said before that you have two tokens available, the internal one and the public one. So this is the case where we're going to use the public token. In here, we are passing that function with the callback to the initializer. So as soon as we initialize the viewer, we are going to call this function, retrieve the public token, and use it to render our model. Just so we don't forget anything, if we go to forge derivatives, forge service dot is this one right here, forge service dot auth, we have the public token only with the viewables read scope. Viewables read scope, as the name suggests, is the scope that only lets us view that our application reads the viewables. The viewables are the translated content from our source file. We're going to upload a Revit file, translate it, and it's going to generate viewables based on what we can see from this file. So a Revit file can have a 3D view and also 2D views for the sheets, for the plan views, and so on. And this is what is covered here. And we also have a function to load a model, a specific model, based on the URN. Remember, URN, use it on the derivative service. URN is the basics for encoded value to identify our specific resource. It contains the bucket key and the object inside this bucket. This is the reference that viewer uses to identify which model is going to be loaded. Alright, this is covered. Now we need to add our application logic. Our application logic is done through this file right here, main.js. So once more, we go under the wroot folder, add a new item, JavaScript file, paste the main.js, and in here we need to copy the content from our tutorial. Alright, now we save it, and we have lots of functions. We are importing here the functions that we just defined on viewer.js, and we have functions to initialize the viewer, to set up the model based on the selection, and we are also have the functionality to upload a model. Remember, we need to upload a model to a bucket as an object, and then we are going to trigger the translation. After the translation is triggered, it might take some time to retrieve from the original source file to the SVF, which is the source that viewer uses, the format that viewer uses. So we need to call the manifest. We need to retrieve the manifest. That's done here, for instance. So here we retrieve the status, which is the response.json, and based on which status we get, we are going to show to the end user our information. Model is being translated. Model is being translated. Model has not been translated. Translation failed. Or the default, which is the model is translated successfully, so we can load the model. All right. We also have a function to show the specific notification based on the status of our models, and we also have a function to clear the notification once we change the object or we select a different model, or the model is being rendered. All right. Let's see. Now is the next step. We handle the application logic and the viewer logic. Now we need to handle our user interface, and that is done through the HTML file, the main HTML file, which is the index.html. We can copy this value, and once more we create it under our wroot folder. We can add a new item, HTML page, paste the content, add the file, get rid of the default content. Now we can copy the content from our tutorial and paste it right here. This controls the structure of our page, how it works, what we have specifically. Here we have a button to upload, the div for the preview, for the overlay, the information, and the model to be rendered. We have an input to input our files, and so on. All right. If you want to change the title of the page, just change it right here. We have also the logo on the header, the nav bar, that we are going to be adding right now. As it says right here, is simply using a select element as the drop down for listing the viewable models, and a button to handle the uploading of any model. Now we need to take care of the style of our application, of our page. We can copy this content right here, and we're going to add the style sheet to our wroot folder. So we go in the new item, style sheet, and we paste the value main.css from our tutorial. Get rid of the default content, copy the one from tutorial, paste it right here. It's handling the overlay of the notification, should be on top of the page, and so on, the position of header, the font family, and so on, all of the styles. If you want to make it different, feel free. We also need to specify the icon and the logo for our page. So if you prefer, you can add one of your company, but if you don't have anyone, the app is gonna work without those, but we show some error messages on console. So to avoid that, let's just download these fave icons. First, our forge fave icon. Let me save image. Let me save it on the desktop. Then I can grab it, and also the logo. Also on desktop. And let's add it under the wroot folder. Let me show it all. No, not all the nodes. Let me use it here real quick. Desktop. Logo and fave icon. So let's open file in browser. In Explorer, sorry. Okay, now we have it here. Fave icon and the logo, just like our tutorial. Alright, now we can try it out. We already have our user interface, but for testing we need to upload a file because our bucket don't have any file to show. So let's see how it works without any file at first, just to check that everything is working fine. If you have any questions, please let me know. Okay, we have it here. Here you can see our image, our logo. And as of now, we have nothing to show. It initialized the viewer, but we have no model to load. So we have an empty down right here. First thing we need to do is upload a model. Before we upload a model, let me show you guys where you can grab a model to use. If you don't have your project files, you can grab those here. We have Revit 2022 sample project files and also AutoCAD. Let me use a Revit one because it contains 3D and 2D view and more information. So let me grab this one here. I always use this one. Let me download it. Let's wait a little bit. If you have any questions, once more. Okay. I'm not gonna open it because it might take some time to open in Revit. And the purpose of this sample is that I don't need the Revit license to read this file, to see this file. So now we can do it. Let's go. But I can't add breakpoints to our, let's see what, our forge derivative service. This is what we call to translate our model. So we are going to reach this endpoint right here, this breakpoint right here. This is where the function we use to get the status of the translation. And also we have this to upload a specific object to our bucket. All right. Yes, and this one here to get the bucket. No, we don't need it. I think we don't need this one. Now let's upload a model. We can select the one, let's go to downloads, the one that we just downloaded. And we reached our upload endpoint. First step, as I said, we are going to upload. We already have the access token, in this case the internal one that has the scopes to upload a model to a bucket. So we pass that. After that we have the response, okay, with the details, the object key, the specific values, and after that it's going to trigger a translation. We uploaded, now we need to translate. And here we have the object ID and the root file name. The root file name is useful for when we have a zip file, a zipped content. So in this case we have a Revit file, so we don't need to provide the root file name, right? So this function is going to trigger the translation. We have the access token. We are specifying the format that we need. In this case, we are translating to SVF, streaming viewer format, the one used by Viewer API, providing the payload. And in this case, we don't have the root file name because we don't have a zip file. So now we trigger the translation. And as you can see, the status is a success. The translation was triggered. Now we need to get the translation status. As I said before, we just started the translation from Revit, from RVT to SVF. So as of now, it might take some time depending on the complexity of our model. All right. This is what this function is checking. Through the manifest of our URN, we are going to know if the translation is already finished or is in process. Okay, let's check this JSON. status in progress. So it says that it's not finished. The translation is not done yet. So we need to wait a few more time before taking advantage of our viewables. And this information is shown through here. We can also have access to how far we have gone with this translation. So we got to 22%, and it keeps retrieving the status until it is complete. Now it's 74. Next time it might be ready. Alright, let's check it. Let's check it. Let's see the root. In progress yet. $94. Now's the time. Let's check it through here this time. Root. Success. Alright, so our translation has succeeded, and now we can verify our viewable through our browser. As you can see here, we can verify which model we are rendering right now, and here is the progress of our rendering. Now we can get access to our geometries, our specific textures for this model, and also the data, the metadata for each of these objects. For instance, if I select this wall right here, I have a button. This button comes by default with the viewer, and it lets me see the properties for the selected model. So if I click on this, I have the family type, specifically is a basic wall, and I have all of its information, its related information, dimensions and everything. Alright, analytical properties, so on. I can have this for any of my elements. Let's say this roof right here. All of the information is available. And also, when we initialize the viewer, it comes by default with these tools right here that you can see. We have tools, for instance, this is really good. We have a first person view. I can go right here, for instance, and start walking in my model. Let me get back to the normal view. We can control the camera. We can take measurements. For instance, if I wanted to measure this distance like right here in millimeters, we can also make sections analytics, analyze through sections. Let me go here. So I can control how I'm gonna see this model. It is good for coordination, for instance. And we can also explode our model right here. And we can see the hierarchy of the model through the model browser extension. If I select this one, for instance, I will isolate only my windows. I can isolate my generic models, can isolate my plumbing fixtures, my floors, here, my floors, my walls, and so on. Alright? If you mention, there is a button that I skipped, which this button right here in the browser. Why I skipped this button? Because this is an extension, a button that doesn't come by default when you load the viewer. You need to specify, oh, I need the viewer to load with this extension. This is an extension maintained by Autodesk, so every time you use the viewer, you can integrate with this function without the need of building a extension itself, but you need to specify, I need those. And this function is useful when you need to change the specific viewable. A Revit file can have this 3D view, but also can have the sheets available. For instance, if I want to see the A102 plan view. I can select that, and now I can see my specific viewable. This is a 2D view. I again, once more, have access to the properties, and I keep doing that for all of the available viewables that got translated from my model. All right, let's wait for it to end loading. All right, the viewer itself, we call it Viewer API, but it's a library that is used with the browser. If you go right here under the HTML, index.html, we are specifying the specific viewer instance that we want to use right here. This is the script that we are using to load our models. This is the library, the viewer library, all right? And in here, as you can see, we have a wildcard with 7 dot asterisks. What this does is that for Viewer API, we have constantly an update of the current version. And with that specified, we are going to use always the most recent version. This is good for debugging, for testing, for development, but it's not good for production because once you are building your application, you are going to test with a specific version of Viewer. And once you finish the development phase and go to production, you only test it for the last version that was available. So if you keep it that, it's always going to download the most recent one. So once you move to production, you need to fix the specific main version, the minor version, and the patch. If you go under right here, under our platform, under documentation, if we go under Viewer SDK, we have access to this change history. For the version 7, which is the most recent version, we have all of these versions available with the release date. So let's say you were developing your application, you started on this date right here, and you'd finish it on this date right here to developing your application. Your application is using this version of Viewer. If you keep it this way, right here, as soon as we release the next version, your application is going to use that. It might have some changes that break your logic. So as a good practice, always remember, go into production, fix the specific version that got tested with you, all right? And also, the other thing that I need to cover with you is the extension. I said to you that we have extensions that comes by default, like the exploding extension, the button to the properties, but we also added one that does not comes by default, which is the Autodesk document browser extension. And here is where it's being added. On the configuration that we pass when we are initializing the viewer, we need to specify which extension we want to use. And those extensions are available on our documentation. If you go right here, under the API reference, we have a space for extension, and you can see all of the extensions that are available. Not all of them, but most of them. And here we have our document browser extension. Here we have some methods for them, and we have also tutorials on how to take advantage of these extensions. For instance, how to write an extension, it will be covered on the third day of this tutorial. But we have the tutorials for div tools, for instance, and lots of resources. All of these resources. I also would like to show you a really great tool for testing the extensions, which is lmv.ninja. Let me see if I can find it through Google. lmv.ninja.autodesk.com. Here, what it does is that it has a viewer for you to test, and it has some models and it has also at the end all of the extensions available with a functionality on that you can simply click on an extension and see how it works. Let's choose the environment first of all, production environment, the endpoints, let's stick with that. Let's use the latest version, and let's select a specific model. Which one? Let's use this house design right here, and we can launch the viewer. Okay, it's loading. Okay, here's our house. It's missing some textures. Okay, but it serves our purpose. So as you can see, it doesn't have the document browser extension, but we can see it right here at the bottom. Now I have to find it. Document browser, document browser, document browser, document browser. As soon as I click here, the document browser should be added. Okay, that's not working. Let's try with a different one. Let's try with a C-levels extension. Alright, and this extension is related to this button right here, and this lets us take advantage of specific levels on our models. As you can see, this model don't have any data. There's another cool one. Let me try the visual clusters. Visual cluster is one really cool. Hope this works with this model. It separates our objects depending on each specific family type, each specific category. So this is a house. It contains floors, railings, for instance, walls, wall sweeps, ceilings, roofs, and so on. This extension is going to separate our elements based on categories and show it with this cool interface right here. And by disabling it, we can turn it back to the normal position. All right. And how we can take advantage of this sample on our tutorial. As this is an extension that comes by default, we can simply copy the name autodesk.visualclusters to our configuration. We can just add a comma here, separate with a comma, and type autodesk.visualclusters. Alright, and as of now, if I push play, I should see my extension added. We have a question. Is it possible to quantify those items? Yes, it is. This is the purpose of the third session of this training, Moses. We are going to build a dashboard out of this information that we have. We have right here, from the translation, we have access to all of the elements with their quantities, their information, so we can configure a way to show this to the end user through a dashboard, through anything, basically. Let's go. It's loading, and as you can see, it was already loaded here. At the side of the document browser extension, you'll have the visual clusters extension. All I had to do was add this extension right here separated by a comma, right? You can do that for all of the extensions available on the Forge platform. I can do it right here. For instance, if I click, I can see all of my elements separated according to the specific category, right? Specific category. We have our roofs, floors, and so on. Cool, isn't it? We don't have only this option. You can also build an extension, as you are going to see on the third tutorial, the tutorial for Wednesday. And we have a GitHub with specific extension. Let me go to Autodesk Forge GitHub. If you go here to the Autodesk Forge GitHub, we can check for the repo with the name extensions, LMV extensions. This is where we have a lot of useful extensions. All right. I guess is this one. No, not this one. Sorry for that. Is the Forge platform. I guess no, it's not this one. Let me try to find it. If you have any questions, please just let me know. Alright, this one right here. This one right here, Autodesk Forge extensions. Here we have a lot of useful extensions, and you can see those through this page right here, forgeextensions.autodesk.io. You can select a simple model. Let's say, let's use this office.rvt, and all of the extensions that you can see through this interface right here, we have the source codes on our GitHub repo. One that I really like is the one for the Google Maps locator. For specific models, we have the geolocation information, so we can take advantage of those to integrate with Google Maps, for instance, to show the specific location on the map, or take advantage of the tracking the objects, for instance. This extension is this one right here, Google Maps locator. As soon as I select this extension, it's added here, and we have an icon for that, and it shows the location of our specific project inside our Google Map embedded. All right, cool, isn't it? If you want to use that, you just need to add the source on your sample and initialize and include the extension, for instance, in here, just like we did for these two options right here. But don't go there yet. We have the third day of our tutorials. It will be entirely focused on extensions and dashboards. All right. Do you have any question? Oh, we have Moses. Is it possible to quantify added visual cluster not showing in browser? Autodesk Visual Cluster. Oh, there's an S, Moses. There's an S at the end. It's Visual Clusters. All right. With that, you should be able to make it work. Is working? If not, you can force refresh your application, your browser. Okay, and that covers what I have to show you for today. Now is your turn. You add the viewer logic, the application logic through viewer.js and main.js, create the HTML page and styles, and that's it. You'll be able to take advantage of this application and improve it with your custom extensions and any of our available services. We are done with the first day of the tutorial, and tomorrow we'll have the Hubs browser, which is basically the same application, but in this case we are not going to manage our files by our Forge app. The files, the storage, is managed by one of the specific tutorials, specific products available, such as ACC, Bin360, Docs, Fusion Teams, and so on. On the third day, Wednesday, we will have the tutorials for dashboards, customizing the viewer with extension, and query design specifically. And on the last day, on Thursday, we'll have the data design automation tutorial. If you need more help, you can find us on Stack Overflow using all of these tags for the specific API that you need help with. And you can also email us to go to support and get help on the Forge platform. After the event, we are going to send you an email with the links to the session recordings. We're going to post it on YouTube. I'm not sure if we will have this on a blog post also. And we will also have links to slides using during sessions, a survey. We'd love to get your feedback, how we can improve. And please, tell the truth. We have tough screen, so we are always trying to improve our trainings. If you have a suggestion about the times that we have, the breaks, maybe a different format that you like most, please feel free to let us know. And also, with your new acquired skills, you can join us in one of our events. We have our lightning talks on our platform. We have our blog with updated content, updated APIs. Every time we have a new API, we are going to post a blog containing samples and tutorials for that. And we also have a program called Accelerator. Actually, let me go there real quick. Let me go here. We have a page for Accelerator. This is the page for our blog. As you can see from our blog, we have a change that we made on the Forge pricing. That's the featured blog, and we have also blogs for any change, for all the most recent changes that we made on our platform. For instance, we had a takeoff exchange for the takeoff module of ACC issues API available as preview, data exchange released, and so on. You can also filter by specific service, specific APIs, specific product. And talking about the events, we have this accelerator that we try to do it monthly, but we have a break in the middle of the year. And what is an accelerator? You have the first step. You are doing going through the first step on our platform, which is going through the trial, learning how it's used, how can you use it to build your application, what is possible to build. But after that, you want to make a proof of concept. Maybe you want to start with your development to move it to production. You want to add a custom integration, for instance. That's why we have this accelerator. You can subscribe with your team in your proof of concept, what you're trying to build, and we have 1 week dedicated with all of our developers, all of our advocates, specialized in viewer API, in ACC, specialized in design automation and all of our features at your disposal. We have support 24 hours from Monday to Saturday to Friday, and on Friday you demonstrate your presentations. So it's really good. We might have a few of them in person this year. I hope so. But if not, feel free to join those virtual ones. All right. You just need to have a proof of concept. Just need to have a project to work on during that week, and also be available to work with that. It's a really great event. All right, guys. Now let me go back, and that summarizes what I wanted to show you, to share with you. Please feel free to reach us if you need more help. And I'll leave this room open a few minutes if you have any questions, any doubts. So just let me know. Thank you for your presence, and I count on with you for tomorrow. All right. Thank you very much. Have a nice day.